right, welcome to 1.3b, where we are going over algebraic proofs. In order to do this, you will want to have your little cheat sheet available where it talks about what each little property is called so that you can fill in the blanks. Okay, so if you look up, when you have an equation and you add something to both sides of the equation, that is called additive property of equality. So, of equality, and I'm just going to shorthand it like that. So the next step, when you did -7 plus 7, and it became 0, that is the additive identity. Additive inverse. Yeah, when you do 7 minus 7 and it becomes a 0, that's called additive inverse. But when the 0 disappears, so 2x plus 0 just becomes 2x because the 0 is disappearing, that's additive identity. There we go. Additive inverse, additive identity. All right, and then when you do 5 plus 7, that is substitution property. I have noticed that some people call it just addition. So sometimes this property has more than one, name to it. Depending on who you're working with, what teacher you're working with, what program you're working with, look for something that talks about how just adding things together and solving, or maybe it's called simplifying. Some people call it simplifying. All right. Next, in order to cancel off that 2x, they did this property where they divided both sides by 2. That is the division property of equality. So when 2 divided by 2 becomes 1, that is the multiplicative inverse. And when the 1 times x becomes just x, that is the multiplicative identity. When you simplify this, it could be just simplify, or it could be substitution property, depending on who you talk to. So simplify or substitution property. Substitution property. Okay, let's look at this one. If you have a problem like this, in order to solve this, you do have to use the exponential property of equality. But before you can apply the property of exponential equality, you do have to do a substitution property. See how 7 to the 4th power equals 2,401? Well, so we are substituting in here. Something that is equivalent to each other. So substituting something that equals each other. And then now we use the exponential property of equality, where see how the bases disappeared and all you have is the exponents, x and 4. They are equal to each other. As long as the bases are equal, then the exponents are also equal. All right, let's go on to this one. Filling in the blanks. So first step, I see that they multiplied both sides by 4 and 7. So when you multiply both sides by the same thing, that property is multiplicative property of equality. Next step, I see that they did some simplifying where they're actually making the 4, this 7 eliminates with that 7, and this 4 eliminates with that 4. So when they're eliminating like that and becoming the ones right here, that is the multiplicative identity or multiplicative inverse. While the ones disappearing is the multiplicative identity. And then, let's see, what are we doing next? Distributive property. Yes, so the distributive property is when you multiply the 7 in, and that gets you 7x minus 35 equals, and we're going to leave this 3 times 4 here still, so that when we do 3 times 4, we can name that the substitution. It's supposed to be a U. Substitution property or simplify. All right. Next, it looks like we added 35 to both sides, so that's the additive property of equality. Okay, we are now going to only apply the additive inverse. So this 7x, these, when they add together, is the additive inverse, creating a 0. And then we will leave this 12 plus 35 to describe its step later. Okay, when that 0 disappears, that is additive identity. And now when these add together and get that, that is substitution property, or also maybe simplify. Okay, looks like they are dividing both sides by by the 7. That is when you do the division. Property of equality. Okay, multiplicative inverse is when 7 divided by 7 becomes 1. And when the 1 disappears, that is multiplicative identity. And it looks like they went ahead and simplified that down to a decimal, so that means they did a subs prop. I would have left it and just stopped there, but since we have this step, we will do the substitution property, making it simplified into a decimal. And it looks like they rounded, because that's what that means. They rounded it. All right, now problem number 4. First step, looks like we are going to do the distribution property. See how the from here to here, the parentheses disappeared, so that's distribution property, or distributive property. Of equality. And then, or just distribution, not of equality. It's just distribution property. And then looks like we are doing some substitution property where we combined some like terms, combine these like terms, combine these like terms. So both of those were simplifying or substitution property. Okay, they want us to do the subtraction property of equality. So that means we are going to minus 16, both sides. And I think that's good enough to show that I subtracted 16 both sides. Okay, next, we are going to look at how it changed. It looks like this became a 0. Meanwhile, they did write out the 1 minus 16 and the negative 3. So since that became 0, that property is the additive inverse. And now they want us to apply the additive identity, so that means we just don't need to, we need to write everything same except for the 0 disappears. Next up, they want us to actually solve that, so that would be a substitution property, or also known as simplify. We will now do the division property of equality, so we will divide both sides by the negative 3. And then when this negative 3 divided by negative 3 becomes 1, that property is called the multiplicative inverse. And then when the 1 disappears, that's multiplicative identity. Okay, when you do this, that is substitution property. Or you can write simplify, whichever one fits you. They're both true. Simplify, there we go. All right, last example, right? Oh, we still have more? Ooh, long notes. Okay, so first off, we're going to do a substitution property. Because this equals this, so we substituted. And next, we're going to do the property, exponential property of equality. Also written, some people write it, the equal, I don't know, I like to write exponential property of equality. I'm so used to multiplicative property of equality, additive property of equality. Yeah, when the exponents are equal, exponential property of equality. Some people write it a different way, but anyways, so you just move this 5 down and an equals and move the x down, and there you go. And the last one, this property, when you swap it around, that is called the symmetric property. Property of symmetry. Symmetric property. Oh, I can't believe we have so many examples of this. Okay, last page of notes. First step, I see that they minused 2x both sides, so that is an additive property of equality or a subtractive property of equality. I think it works either way. Additive property, subtractive property. I'm going to write subtractive property of equality. And then we only changed this. Notice that everything else stayed the same, including the 5x minus 2x. So 2x minus 2x became 0. That is the additive inverse. When the 0 disappears, That's additive identity. Next up, I'm going to do a substitution when these, you add them together, and they become 3x. It says do the subtraction property of equality next, so I will subtract 10. There we go. Showed my work for subtraction property of equality. I'm going to only apply the additive inverse when I make this become a 0. And I still need to write out the 25 minus 10 equals 3x. And then I will make that 0 disappear, and notice that everything else is still there. So that means I applied the additive identity. And now we combine these, and we'll call that substitution. And we divide it by 3 both sides. That's the division property of equality. Just apply the multiplicative inverse. That means this 15/3 doesn't change, and the 3 divided by 3 becomes 1. Apply the multiplicative identity, so we have 15/3 equals x. And lastly, 15/3 became 5. That is when we did another substitution or simplify. And we do one last step, because we like to have the x equals 5 instead of 5 equals x, and that is the symmetric step. Yay, we made it. That is the end of those notes. Good luck on your assignment.